All right, welcome back to Mr. PL's with Geometry. Is Unit 1, Topic 2, and day number 2. Writing a function rule for translation. So for these next two videos, we're just going to strictly look at translations other than this warm-up. For this warm-up, this is a little tricky of a question here. I know it does look like it's a rotation, but if you look at the fish carefully, it's facing the origin. And if it was a 180-degree rotation, it turned all the way around, it would still be facing the origin, and it's not. So no, technically, this is not a rotation. If it is a rotation, we would need to do something after that rotation in order to turn it into this, like a reflection. The second one is definitely a rotation. That's a yes. This one is also a rotation. It's a 90 degrees, either clockwise or counter, depending on which one you think is the pre-image. And this one's a reflection, so that's a no. Now, these two down here could actually be a couple different things. This over here could be both a reflection if you flip it. It could also be a 180-degree rotation. This one over here could either be a translation that's been slid straight down or up, or it could be a reflection over this line of symmetry, which is the x-axis. All right, so on page 14 of our packet, so we have translate CY 4 spaces to the left. So all you have to do to translate something is to simply move it 1, 2, 3, 4. So I'm going to put C prime right there because that's a copy of C. And then 1, 2, 3, 4. There's Y prime, and what you'll notice is that this segment is exactly the same length as the original. For the next one, it says 2 spaces up, so I move both points 2 spaces up. There's D prime, there's M prime, and once again, it's a rigid transformation. So this line and this line are exactly the same. Now, this is the exact same direction, only difference is now we have 3 points, so we have a triangle. So in this case, it says 1 space up. So I just simply move each one space up from its previous position and call it prime. When I connect them, yes, the triangle should be the same shape and same size because it's a rigid transformation. Same goes for this next question. It says 3 spaces down, so n becomes right here at n prime. 1, 2, 3 is D prime. 1, 2, 3 is Y prime. 1, 2, 3 is R prime. Connect them up, and yes, we have the exact same shape underneath. All right, so pretty much the exact same directions here, but we're going to be doing 2 things. 4 spaces left and 3 spaces up. The order does not matter when doing more than one translation. So 4 spaces left, 1, 2, 3, 4, and 1, 2, 3 up. So there's position for L prime. 1, 2, 3, 4, 1, 2, 3 is I prime. 1, 2, 3, 4, 1, 2, 3 is S prime. 1, 2, 3, 4, 1, 2, 3 is F prime. And 1, 2, 3, 4, 1, 2, 3 is Y prime. Once I connect them all up, ladies and gentlemen, it is going to be the exact same shape, only it's been slid to the left and up. All right, doing just one more of these as an example, it says, describe a series of transformations. Okay, these directions are actually different. So always start at the pre-image. Notice this is the pre-image because there's no prime symbol. This will always be the final image. So it's like the start and the end. It's very important that you make sure you're going the correct direction. Otherwise, you're going to have the exact opposite direction. So that's 1, 2, 3, 4, 5, 6. So this is 6 right. When I look at this question, I notice this is the pre-image and this is the final image. I just pick one of the points. It doesn't matter which one because it is a rigid transformation. It should be the same translation movements for both points. Up 1, 2, 3, 4. So that's this one's up 4 and 1, 2, 3, 4. Oh no, it's up 5. Sorry, I miscounted. So it's up 5 and left 1. All right, so I'm going to skip through that. So on this question, so what it has you to do is find the point D, which happens to be at 12, 5. And then move that pre-image 5 spaces to the right. So 1, 2, 3, 4, 5. There's D prime. Now that happens to be at 17, 5. Now, hopefully what you're noticing is that the Y stayed the same and the X increased by 5. Because anytime you move to the right, you're getting bigger numbers. When you're moving to the left, you're making numbers smaller. So to write this as a rule on the next page, actually before we get to that, now if I pick another point like G, I'm trying to get ahead of myself here. So if I pick another point like G, 1410, and then I move it the same amount to the right, which is 5. 1, 2, 3, 4, 5. I should not be shocked that G prime ends up at 1910, because like I said, we added 5 to the x and the y stayed the same. Now, what if we were doing a point that could not be graphed on that grid? 482, that's a lot to the right and a lot up. I know this number is going to increase by 5, so it'll be 487, and I know this number will stay the same because I'm only moving right, I'm not moving up. The second number is up or down. The first number is left or right. So remember, we have an x comma y. X either moves things right or left, depending on whether or not it's positive or negative. And y moves things either up or down, whether or not it's positive or negative. So just like a grid, this is the x-axis, this is the y-axis. We go positive this way, negative this way. Positive up, negative down. So if you just remember how a grid's set up, it's done exactly the same. So we're adding 5 to whatever the x is, and we leave y, y. So we have our input and our output. The input gets increased by 5, and the output stays the same. It's the same rule that we did for this point, even though we did not graph it. All right, so in the next video, we will be using the same concept to both find rules and find points when given a rule. Thanks again for watching, and have a wonderful day.